Okay, metals with two charges. So metals with two charges are going to, in the naming world and in the formula writing world, it matters what they're charged. So we have a lot of them. And I try to teach you them. And so we have things like iron. It could be +2, or it could be +3. Well, if it's +2 and it bonds with oxygen, it forms a very different formula than if it's +3. If it's +2, these guys cancel out already. +2 minus 2 cancels out, right? So the formula is just Fe. Oh, okay. But if it's a +3 charge, so if we did +3 over here, so if I did +3 minus 2, now it's not such a simple cancel out. We need to flip-flop the charges, like our trick. Okay, and so we would need Fe2O3, because I need my charges to cancel out. And so this formula and this formula are very different from each other. One only has one oxygen, one iron, one has 2 irons and 3 oxygens. And so we have to clarify which one, right? So when we name it, I can't just say this is iron oxide, because how do I know which formula I'm talking about? I don't, you don't. And that makes a big difference. So you need to make sure that you're telling them which one, because then you have different numbers of atoms and they're going to react differently, and we'll get into that stuff later, but realize that these are 2 different compounds that are not going to react the same. And so we need to make sure we know which one's going on. And so we do that by our naming. And so all you have to do is say the charge in the name. So instead of just saying iron oxide, I would say iron 2 oxide. And we do it in Roman numerals when we write it out. But iron 2 oxide is how you'd say that. And so then they know it's the +2 charge. For this one, I would say iron 3 oxide, and I would know it's the +3 charge. So how you would write that one out would be iron, Roman numeral 3, and then oxide. Okay? And so that's all you're doing to name those. That's the one extra step. But then on the flip side, if I were to tell you the name of them, and I want you to write something, you would also need to know. So for instance, tin. Tin is one of our metals that has either +2 or a +4 charge. So if I said I had tin 4 oxide, okay, tin is Sn. This 4 means I have a +4 charge. Now oxide's always oxygen, it's a -2 charge. So then I need to write that formula. And so then what I can do here is I can just quickly crisscross. So I could say, hey, 2, and then I can say 4. But guess what? SN2O4 can be reduced, so I want to write it as SNO2. Okay? Why do I want to write it as SNO2? That little trick right here, why didn't that work and give me the right formula immediately? Because we want to reduce. And so a different way to look at it, if I were to rewrite this for you, would be to say 10 plus 4 and then O minus 2. If you look at these and say, okay, well, +4 minus 2 equals a +2 charge, then our next step would be to add another negative. So if I add another negative, now I have a +4 minus 4 charge, and then I'm at 0. So it just needs, we just want the minimum work that we have to do. Okay, and so that's how we would reduce, and that's how you're going to do metals with 2 charges. The most complicated thing that I can give you is a metal with 2 charges and a polyatomic ion, which is not the most complicated thing, but it's not the worst thing in the world, I should say, but it's the most complicated thing that you'll see in this class. So that being said, that's kind of how we name and write formulas for ionic compounds.